Assalamualaikum everyone. So in today's class, we will solve some example of inverse trigonometric function. So in the earlier classes, we have discussed about how to find the inverse of a function. The function is given and the range and domain for the inverse trigonometric function. Okay. According to that, the principal values of that inverse trigonometric function, we will solve some example. Here in this column, you are having inverse trigonometric function and the range for inverse trigonometric function, all six inverse trigonometric function, and this one is the domain for the inverse trigonometric function. According to these values or by using these values, we can find the inverse of a given trigonometric function. Okay. First question is find the principal value of sine inverse of minus 1 by 2. Okay, it is given to you. So firstly, now let's solve quick solution. First consider y is equal to sine inverse of half or minus 1 by 2. Okay, so we can take this inverse here. This implies if I am taking this inverse here, it will become sine y is equal to minus half. Okay, so now we have to write by using the table value of the sine function. Sine 1 by 2 is the 1 by 2, sorry, sine 30 is 1 by 2. In radian, if we are taking in terms of a radian, then it is pi by 6. Okay. Sine inverse of minus pi by 6. So you know that sine minus theta is minus sine theta. Okay, by using this, I am writing minus pi by 6. Okay, now see here, we know that I will write these questions afterwards. We know that the sine range of sine is, or the principal value branch of sine is closed interval minus pi by 2 and plus pi by 2. Range of sine inverse is sine inverse equal to minus pi by 2 comma pi by 2. So see here, minus pi by 6 lies in between these two. Okay, these two values. So the principal value of, right, this is for principal. Okay, principal value of sine inverse of half minus half is minus pi by 6. Okay, so see here, we have to check whether these values, which is after finding the table value of by using sine function, we have to check whether these values lies in between the principal value range or the principal value branch. If it is lies, then you can write the principal value of the given question is, given function is so and so. Okay, now for second one, we take solution. Let y is equal to again cos inverse of root 3 by 2. Okay, see, if we are taking this cos, it goes into numerator. Cos y is equal to root 3 by 2. Again, we have to check root 3 by 2 in cos table. We know that it is cos pi by 3. Cos 60 is root 3 by 2. Okay, by using the table value of cos 60 is root 3 by 2, in terms of radian it is pi by 3. So cos y. So this implies y we have taken cos get cancelled, y we have taken as cos inverse of root 3 by 2. So cos inverse of root 3 by 2 is pi by 3. Okay, now we have to check whether these values lies in between the range value for cos. Cos inverse, the range of cos inverse is, range of cos inverse is of x is 0 to pi, close interval. So pi by 3 means 60, cos 60, it lies in between, sorry, this one is, this value is for cos 30. Okay, this value is for cos 30. Cos 30 is root 3 by 2, sin 60 is root 3 by 2, the inverse we have to take. So it is cos 30 and this one is correct. Okay, so this implies the principal value of Cos inverse of root 3 by 2 is what? Pi by 6. It is very simple. First, we have to consider the given function as y. Now, this cos we have to take, then it becomes in the one. It is cos inverse is 1 by cos. We can take. So, by the cross multiplication, it goes into numerator cos of y is equal to. Now, we have by the table value, by using table value, we have to write cos value. Okay. Now, whatever value you will get, we have to find we have to check whether this value lies in between the principal value branch of the given function. If it is lies, then we can write the principal values. Okay. So now write down another questions. For to solve this such type of question, it is very important for you to remember the table value of for all six trigonometric ratios and the branch principal value branch also. Then it will be easy for you. Now write down another question. Cosec inverse of 2. I'm writing all questions, then I will solve. Okay. Tan fourth is minus root 3. Sec inverse of 2 by root 3. Cot inverse of root 3. So let's solve some these example. One by one, I will show you the solution. Now take second question. Third one is cosec inverse of 2. Write down solution that y is equal to cosec inverse of 2. Okay, so we can write this 1 by cosec x. Cosec x goes into numerator, then it is cosec y is equal to 2. Now we in the table by the using the table value for cosec x, we have to find this root 2. You know that cosec is the reciprocal of sine and sine 30 is half. So here we can write cosec 30 is half, means reciprocal means it will become 2. So cosec pi by 6. Okay. So this cosec get cancelled. We are having y is equal to pi by 6. So y we have taken as, this implies y we have taken as, or you can write in this way. This cosec both side cancel, we get pi by 6 y. But we have taken y as cosec inverse of 2 is equal to pi by 6. So we have to check whether these values lies in between for the cosec interval, whether pi by 6 lies in between the range value, principal value branch. So for the cosec we are having closed interval minus pi by 2 to plus pi by 2 and minus of 0. So pi by 2 means 90 and pi by 6 is 30. Means it lies in between these two. It is the interval minus 90 to plus 90 and it is a positive 30. Then it means these values lies in between. Okay. So we have to write range of cosec inverse equal to minus pi by 2 to pi by 2, but it should be noted it is a closed interval. Okay, minus of 0. So this implies, therefore the principal value of cosec inverse of 2 is nothing but pi by 6. So to solve such type of question, It is very important to remember the table value. For cosec 30 it is 2, for cosec 60 means all 6 ratios. At least you have to remember the values from table value from 0 to 90. Okay, then you can easily solve this. It is for cosec. So now remaining we are having remaining 3 for tan, sec and cot. Now if you want to copy, you can copy it. Okay, now write down fourth one. Our fourth question is tan inverse of minus root 3. Tan inverse of minus root 3. Now again you have to take let y is equal to tan inverse of minus root 3. Okay. So this tan goes here. Then it is tan of y is equal to minus root 3. So root 3 value we have to check in the tan table. Tan 60 is root 3. Okay. So tan 60 is root 3 means in terms of radian it is 60, in terms of degree, in terms of radian it is pi by 3. So right here tan of minus pi by 6, and you know that tan minus theta is, we can write minus tan theta. Okay, so you can easily write it is minus tan of pi by 6, pi by 3 it is, sorry, because it is 60 means it is pi by 3. So tan of y, here both sides tan and tan get cancelled, y is equal to minus pi by 3, or we can write y we have taken as tan inverse of root 3. Tan inverse of minus root 3 is minus pi by 6, 3. So we have to check, and what is the range for the tan inverse? It is the open interval of pi by 2 and minus pi by 2, minus pi by 2 to plus pi by 2. So the range of tan inverse is here is, it is open interval, it should be remember always, it is an open interval minus pi by 2 to plus pi by 2. So you have to check whether these values rise. So 90 it is, pi by 2 means 90, plus and minus 90, so it is minus 60, so it lies in between the principal value branch for tan. So we can write here, therefore principal value of tan inverse of minus root 3 is minus pi by 3. Okay, so first we have to take the given question as, or the given any function as y, then we have to take shift this, it is a tan inverse, we can write it 1 by tan, then the denominator on the right hand side becomes the numerator here. So tan of y is equal to minus root 3. We have to check root 3 value in the tan table. It is tan 60. On tan 60 we are having root 3. So it is minus of root 3 is given to you. So it is minus root 3 by minus pi by 6, sorry, pi by 3. So minus tan theta is here. Tan minus theta is minus tan theta. So we can easily write. After getting this value, we have to check whether this value lies in between the principal value branch for the given in function, which is given to you as tan inverse. If it is lies in the principal value of the given function tan inverse root minus root 3 minus pi by 3. Okay. Now write down fifth one. For here you are having sec inverse of 2 by root 3. Sec is the reciprocal of cos, you know. So here let again y is equal to sec inverse of 2 by root 3. It goes here and then it becomes, this implies sec of y is equal to 2 by 3. By using the sec table value for sec, we have to write 2 by 3 in terms of sec. Then it is, you know that cos 30 is root 3 by 2. And sec is the reciprocal of cos. So you have to write sec of pi by 6. Okay. Sec of pi by 6 means 30. Cos 30 is Sin 30 is half, cos 30 is root 3 by 2, and sec is the reciprocal of cos. That's why we have to write pi by 6. Here both sides sec cancel. What is remaining? Y. Y is equal to pi by 6, but we have taken y as sec inverse of 2 by root 3 is equal to pi by 6. Okay. So the range or the principal value of the value branch for sec inverse is 0 to pi close interval minus pi by 2. 0 to pi, it is in the closed interval, minus pi by 2. So pi by 6 is 30. 30 lies between 0 to pi. Okay. So it is therefore principal value of sec inverse of 2 by root 3 is pi by 6 here. Okay. This is most important. Means if you know the principal the table value, then only you can write the given value in terms of radian, in terms of trigonometric ratio, in terms of the value of trigonometric ratio. Then you can go for the solution. Okay, this is very important. Now lastly we are having, if you want to copy, you can copy it. Okay, now lastly we are having cot inverse of root 3. Cot inverse of root 3. Again let y is equal to cot inverse of root 3. This implies cot of y is equal to root 3. So root 3, we have to again write the root 3 in terms of cot using the table value for the cot. You know that cot is the reciprocal of tan, and if you know the value of sine, cos and tan, then remaining 6 you can easily write, because remaining 6 are the reciprocal of the sine. Cosec is reciprocal of sine, cos sec is reciprocal of cot, and cot is reciprocal of tan. So if you know these starting these three values, then easily you can write for this. So we know that tan 60 is root 3. Here it is cot inverse of cot 1 by root 3. Root 3, it should be 1 by root 3, which I will check. We will check. We can also check. We know that sine 30 is half, cos 30 is root 3 by 2. Okay. So if tan 30 is here, tan 30 is sine by cos 1 by root 3. Now cot 30 is root 3. In terms of radian, it is pi by 6 root 3. Okay. It is very simple. Cos 30 is half, sine 30 is half, we know that, and the cos 30 is root 3 by 2. So tan is sine by cos, that means these two to cancel, 1 by root 3. So tan 30 is, we got 1 by root 3. Cot means reciprocal, then it is root 3. So 30 in terms of radian is pi by 6. Okay, so we can write here cot of pi by 6. So here both sides cot get cancelled. What is remaining? Y is equal to pi by 6, but we have taken y as cot inverse of root 3 is equal to pi by 6. We have to check whether this pi by 6 lies in the principal value branch of cot inverse. Cot inverse principal value branch is the upper interval 0 to 5. So the range of cot inverse is open interval 0 to 5. So pi by 6 is 30. It lies in between the principal value branch for cot inverse. So we can write the principal value of cot inverse is cot inverse of root 3 is pi by 6. Okay. So all 6 for the principal value for the given function, we have taken 6 examples including all 6 trigonometric ratio. Now in the second bit we will solve, we will find the domain. Here we have find the range for the given trigonometric function. Now in the second bit we will find the domain for the given trigonometric function. Find the domain of, write down, find the domain of the given inverse trigonometric function. Find the domain of, write down questions. I will write all questions and then I will write the solutions. Okay. Function is given to you. First one, f of x is equal to sine inverse of x plus cos x. Okay. Second, sine inverse of x plus sine inverse of 2x. Third, cos inverse of 2x minus 1. Now write down the solution. Here it is, the function is given to you, f of x is equal to sine inverse of x plus cos x is cos x. So sine inverse x domain is closed interval minus 1 to n. 1. And what about cos x domain? We know that cos x is domain is nothing but the values on the x-axis. On the graph we see that we have discussed the value of sine x-axis on the cos, the graph is all real numbers. Okay, so here we have to write for this the domain is closed interval 1 minus 1 comma 1, and for this we are having the real number. The plus means you have to take union or the intersection of these two. Sorry, here you have to take the intersection of these two. Intersection. Real, on the real number line, minus 1, 1 both lies. So we can take the domain as minus 1, close interval, minus 1 and plus 1. Okay. For to solve such type of example, you should have to remember the domain value for all these 6 trigonometric functions. Sine inverse, we are having domain as close interval minus 1 and plus 1, and the domain for cos x is r. So we have to take plus sign means we have to take intersection of these two. So on the line, real number line, we are having real numbers. We know that 1 and minus 1 lies. So the domain for f of x is close interval minus 1 and 1. Okay. Now take second one. For the second one, sine inverse is given to you. If inverse is given to you, you have to take domain this. If just the direct question like cos x, sin x is given to you, you know that for cos x, sin x, the domain value is set of real numbers r. Means on the x-axis we have discussed already. On the graph for the cos x and sin x and the other trigonometric ratio, the x values are all real numbers. We have to take for trigonometric ratios domain R, but for inverse trigonometric function range values is different. Okay, because we have restricted to make the given function as 1 1. Here sin inverse of x is given to you. For sin inverse of x we are having domain as close interval minus 1 and 1 plus. For sin inverse 2x is given to you. For sin inverse of x we can take directly close interval minus 1 and 1. But here sin inverse of 2x is given to you. For this we have to take, we know that the sin inverse domain is plus 1 and minus 1. So we have to write in this way 2x. Okay, because here 2x is given to you. I am taking divide these two by these by 2, then we will get minus half is less than equal to x, it is less than equal to plus half. Divide this equation by 2. Then you can see x is lies in, for this function sin inverse of 2x, x lies in between plus half and minus half. Now we have to take the intersection of these two interval. Intersection of minus 2 and comma 2. Minus half and plus half. Okay, minus 1 by 2 and plus 1 by 2. So minus 1 by 2 plus 1 by 2 and minus half minus 1 and plus 1. So the intersection is, you can see what will be the intersection. We have to take minus half comma plus half. Okay. Now our third question is cos inverse of 2x minus 1 is given to you. You know that the domain value for the cos inverse is, it is again close interval minus 1 and plus 1. So here we know for cos inverse domain is minus 1 and plus 1. But it is for cos inverse of x. Here cos inverse of 2x minus 1 is given to you. Then you can write 2x minus 1 and plus 1. Now we have to find the x value, then it will be our domain. So I am taking this minus 1 on both sides, on LHS and RHS. If I am taking this minus 1 here on LHS and RHS of this equation, then it will become plus. So minus 1 plus 1, 2x less than equal to 1 plus 1. Okay, here it will become 0 less than equal to 2x, 2. Now divide this equation by 2. Because here we are having 2x, we have to find the value of x only. So 0 by 2 is 0 less than equal to x 2. To make this one only x term, this term x, we are dividing this by 0. Here, 2. Right here divide by 2, then we will get here. Okay. So this means our domain is cos 0 and 1, close interval 0 and 1, or we can write here. So this implies domain for the function f of x is close interval 0 and 1. Okay, if you know that the domain value for the inverse trigonometric function as well as for the trigonometric function, then only you can write solve such type of examples. If you know the domain, then it is very easy for you. Okay, just you have to write the domain for both function. If it is not given to you directly, sin inverse, cos inverse, and only for the inverse function you are having, but it is given to you in terms of 2x, in terms of 2x minus 1, then you have to find the value of x by using this method. Then you can easily write down the domain for the given function, inverse trigonometric function. Okay. So in the first 6 example, first week we have discussed about the principal value branch of the inverse trigonometric function. Okay, now in the second we have seen how to find the domain of the given inverse trigonometric function. So write down some other examples. The range, if you know the principal value branch of the inverse trigonometric function, and the domain on, then it is easy for you to solve this type of examples. Okay, write down questions. Here you are having sine inverse of cos 3 pi by 4. Sine inverse of cos 3 pi by 4. Okay, write questions, then we go for solution. Sine inverse of cos sine inverse of root 3 by 2. Write down solution. Okay, sine inverse of what is given to you? What is given to you? Sine inverse of cos 3 pi by 4 is given to you. We have to write cos pi by 4 in terms of pi, because you know that cos of minus theta is cos plus theta. If we are having cos minus theta and we want to write in terms of minus, then we have to write cos of pi by pi minus theta. Cos pi minus theta we have to write. So here we are using this cos of pi minus theta. The theta remains same as it is. Okay, so we have to take sine inverse of cos pi minus pi by 4. So now we can write sine inverse of cos pi by 4 is, now we can write easily cos pi by 4. Cos pi by 4 value you can easily write here. Cos pi by 4 value, you know that it is half 1 by root 2. So sine inverse of 1 by root 2 is pi by 4. Okay. For first we have to solve for this cos of 3 pi by 4. It can be written as pi minus pi by 5. Why we are writing? Because it is sometimes you will given to you as a complicated value, so you can't find easily on the table value. So to make it easy, we are writing pi minus pi by 4. If you are taking LCM, it is 4 minus 1 3 pi by 4 as it is. Okay. So pi by 4 we know, cos pi by 4 value we have to write. Cos pi by 4 value is root 1 by root 2. So sine inverse of root 2, 1 by root 2 is pi by 4. Now take this one. For here you are having three trigonometric ratios, sine inverse, cos and sine inverse. First we have to solve for this. Okay. Write first and second term as it is, sine inverse, then cos of sine inverse root 3 by 2 is, we know that it is pi by 6. Pi by 3. Sine 60 is root 3 by 2. So we are writing here 16 is in terms of radian pi by 3. So now sine inverse of cos pi by 3 means cos 60 we know that it is half. So sine inverse of half is means we know that on the table value sine 30 is half. So 30 is in terms of radian, it is pi by 6. Okay. Write down another example. And sorry, it is here we have to write minus, because pi by 4 is 1 by root 2, but we are having minus pi by 4. We have to write here also it is minus, and this one is belong to the range of minus pi by 2 and plus pi by 2. It is also belong to the range of pi minus pi by 2 and pi by 2. Okay. Now write third one, tan inverse of sine minus 90 or minus pi. Sine minus pi by 2. Sine minus pi by 2, for first we have to write sine minus pi by 2 is sine 90. Well, we all know that it is 1. Minus 1 we have to write. Tan minus theta is minus theta. Minus tan inverse of 1. So our tan inverse 1 value we know that it is pi by 4. pi by 4, minus pi by 4. Again it lies in the interval. For tan we know that it is, for tan it is open interval of plus and minus 90. Okay. Now write down the fourth question. Fourth one is here you are having cot sin inverse cos tan inverse of 1. Totally here we are having four trigonometric ratio: cot, sin, cos and tan. So first we have to write cot as it is and sin inverse as it is. Now cos as it is, and tan inverse 1 we know that it is pi by 4. On pi by 4 we are having tan value as 1. So now close the bracket. So now write cot as it is, sin inverse as it is. Cos pi by 4 we know that cos pi by 4 is 1 by root 2. Now cot as it is, right? Sin inverse, we have to always remember, we have to start writing the solution from this. First solve for this, then for this, lastly cot. Sin inverse of 1 by root 2 is pi by 4. Sin pi by 4 values is. So you know that cot pi by 4 is, cot pi by 4 is, cot pi by 4 value is 1. Okay. Cot pi by 4 is 1. So here in this class I have explained the principal value branch of how to find the principal value branch of inverse trigonometric function and the domain of the inverse trigonometric function. Here how to solve such type of examples. Okay, first we have to solve for these values with the inner bracket, then we have to go for the outer bracket or the bracket outside the term. Okay, if you know the table value, then it is very easy for you. In the first we are having cos 3 pi by 4, it is not given. It is here in the table value you are having values from 0 to 90 and it is easily remembered for us. Easy to remember for us. That's why we have wrote this value in such a easy way, so we can easily find the table value. So cos pi by 4 we know that it is minus 1 by root 2. Here we are having minus, that's why we are taken here minus. So sin 1 by 2 root 2 is pi by 4. We all know that. And these values is lying in the principal value branch of sin inverse. So we have wrote here cos interval half plus 90 minus. In the second one also cos 60 sin inverse of root 3 by 2. Sin 60 is root 3 by 2. So we have wrote sin 60. Now first, second, third we are having three trigonometric ratio. First we have to solve for last term. Sin inverse of root 3 by 2 is 60. Sin 60 is root 3 by 2. Now for cos, what is remaining? Cos of pi by 3. Cos pi by 3 is 60. Cos 60 means cos 60 value is half. So now sin inverse of half is remaining. Sin inverse of 1 by root 2. Sin inverse of 1 by root 2 we know that by the table value sin 30 is half or 1 by 2. So we have wrote pi by 6 belongs to the closed interval. This why we are writing in this bracket, because the principal value branch of sin inverse. Okay, what is the remaining last term? For that we have to write the principal value branch. In the third we are having sin and tan ratio, trigonometric ratio, sin inverse and tan. Tan 90 we know that it is minus 1, but it is minus pi is given to you, so we have wrote minus 1, because sin minus theta is minus sin theta. Okay, so by using that property we have wrote here 1. Tan inverse of minus 1 is here again minus tan inverse of 1, because tan minus theta is also minus tan. 1 is we know that tan on tan 45 is 1. 45 is means in terms of radian it is minus pi by 4. Okay, lastly we are having 4 trigonometric ratio: cot, sin inverse, cos and tan inverse. Tan, first we have to write the last term. Tan inverse 1 is pi by 4. Okay, by the using table value. So cos pi by 4 we know that it is 1 by root 2. For sin inverse root 2, 1 by root 2 is cot pi by 4. So the cot pi by 4 is 1. Okay. Okay, thank you. Jazakallah. So it is very easy if you know the principal value branch, domain, and the table value for the trigonometric function, then it is very easy for you to understand. But if you want to solve the many examples you are having in your textbook, if you also want to solve another, you have to first you have to practice this, which I have taken in today's class. Then go for the another questions. If you are finding any difficulties for solving such type of another example, you can ask me. Okay, thank you. Jazakallah.